So in this video, we want to look at how to simplify surds. It's a bit like simplifying fractions, where we want to write something in its simplest form. So instead of 3/6, we'll write 1/2. And they mean that they have exactly the same value, but 1/2 is just simplified. So same thing here, root 12. What we're going to do is look at this in reverse, almost from when we expand or multiplied fractions. Surds. When we know that root 12 is root 4 times root 3. Now I know that that's because 4 times 3 is 12. But I also know that the square root of 4 is 2. And so when we write that, we can just say that's 2 root 3. And looking at the second part of the surd, root 3, I can't simplify it any further. And so I know that I've simplified that fully. So our second example then, if we have something like square root of 48. Well, again, I know that root 4 goes into that. And it's 4 times 12 gives me 48. So root 4 times root 12 gives me root 48. And so the square root of 4 is 2 root 12. However, if you look, root 12 we've already simplified. So this is not the most simple form of this. And actually, if you look a wee bit more carefully, 48 is also 16 times 3. So root 16 times root 3 is root 48, which is 4 root 3. And that shouldn't be a surprise, because look, root 12 we've seen is 2 root 3. So if we say root 12 is 2 root 3, then 2 root 12 is 2 times 2 root 3, which is 4 root 3. And so we get exactly the same answer either way. And sometimes these numbers will jump out at you. 4 times 3 is 12, and I know the square root of 4, so that's easy enough. But sometimes maybe 4 12s is more obvious than 16 times 3. So we need to find a way that this would work all the time. And I think a way of doing that is by splitting numbers into their prime factors, or product of primes, like this. If we say 48, well, the first prime number that goes into 48 is 2, and it goes in 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. And the only prime number to go into 3 is 3. And so we can say, like we've done since down to school, that 48 is equal to 2 times 2 times 2 times 2 times 3. Okay. These factors we multiply together. They are products. The product of primes, we say 48 is written in its product of primes. And there's only one way you can do that, 2 times 2 times 2 times 3. But we know then, if I want to work out what root 48 is, it's just root 2 times root 2 times root 2 times root 2 times root 3. And also we've seen that when we multiply surds, when you multiply a surd by itself, well, root 2 times root 2 is simply 2. Root 2 times root 2 is 2. And so what we've got here is 2 times 2, and just left on its own is root 3. And so 2 times 2 times root 3 is 4 root 3. And so a little bit extra work writing things in terms of product of primes, but when we do it like this, we'll always get it simplified as much as possible. So let's have another look quickly at an example here. So let's say root 60. Well, I can't think of maybe a prime number goes into, a square number goes into 60 easy enough. So I'm going to take this to one side and say 60. Well, I know 2 goes into 60, the prime number. So it leaves goes in 30 times. And 2 goes into 30 15 times. 3 goes into 15 5 times. And 5 goes into 5 once. So we see that 60 is equal to 2 times 2 times 3 times 5. That means that root 60 is root 2 times root 2 times root 3 times root 5. Now again, we can pair them up here. Root 2 times root 2 is just 2. And root 3 times root 5, well, they don't cancel out the square roots, but I can multiply root 3 by root 5 just normally and say that's root 15. And so root 60 then is 2 times root 15, or 2 root 15s. Now how that then helps is we can use that for something like this, root 27 plus root 12. Now we've already seen that root 12 is 2 root 3. And if we take 27 to one side, you'll see that, well, 2 doesn't go in, but 3 goes in 9 times. 3 goes into 9 3 times, and 3 goes into 3 once. So root 27 is equal to root 3 times root 3 times root 3. And in this case, root 3 times root 3 is 3, and we've just a root 3 left over. So it's 3 root 3. So going back to our original question then, root 27 we write as 3 root 3. And when we have 3 root 3s plus 2 root 3s, we can add them together to get 5 root 3s. So we can use this simplifying individual surds like this to help us do additions and subtractions as well, and see if we can add and subtract different surd terms. We also need to be able to expand brackets with surds as well. So something like this, 2 plus root 3 upon 4 plus root 3. Again, when I do this, sometimes I use the FOIL method when we had brackets before. It's FOIL standing for the firsts, the outers, the inners, the lasts, and with different ways of doing this, but essentially I'm going to multiply the firsts together. So 2 times 4 is 8. The outers, so 2 and root 3, well 2 times root 3 just gives me 2 root 3. The inners, root 3 times 4, well that just gives me 4 root 3s, or 4 root 3. And finally, the lasts, well, root 3 times root 3. And again, root 3 times root 3 just gets rid of the square root, so we just end up with 3. Or root 3 times root 3 is root 9, which is 3. And now it's just a matter of simplifying things down a bit. We have 2 surd terms and 2 constants, 2 integers that we can add together. So 8 plus 3 is 11. 2 root 3 plus 4 root 3 is positive 6 root 3. And so we've expanded that bracket, set of brackets, and we've simplified it down. Second example, same sort of thing. It's just 3 minus root 2 upon 4 plus root 3. And again, when we look at the first terms, 3 times 4 is 12. The outer terms, 3 times root 3 is just 3 root 3s. The inner terms, minus root 2 times 4, well that's minus 4 root 2s. And then the final terms, the last terms, minus root 2 times root 3, well a positive times a negative is negative. Root 2 times root 3 simplifies only to root 6. And so in this case then, not much that we can simplify any further in this. As you can see, we have a root 3 term, a root 2 term, and a root 6 term. And that's like trying to add an x, a y, and a z. They're different, so we can't add them together. Final example here. Again, when we've expanded brackets, we've seen something like this: 1 minus root 2 all squared, the bracket all squared, which we know means, well, you multiply the bracket by itself. So it's 1 minus root 2 upon 1 minus root 2. So again, first 1 times 1 is 1. The outers, 1 times minus root 2 is minus root 2. The inners, minus root 2 times 1 is again just minus root 2. And finally, the lasts, well, minus root 2 times minus root 2, well, a negative times a negative is positive, and root 2 times root 2 is 2. Now again, can we simplify this any further? Well, yes, we can. We've got 2 whole numbers here. 1 and 2 is 3, And minus root 2 is minus 2 root 2. So overall we can simplify this to 3 minus 2 root 2.